Don't want me to start by saying this? Fuck part B, dude. Oh my god, that's gonna be miserable. Let's just do part A first. So maybe we should start by writing down what we think is gonna happen, write down our general hypotheses. We got t less than 0, t greater than 0, what happens? Okay, we're talking about inductors. So if this is closed, so if it's not closed, so t less than 0, it's open. And if it's t greater than 0, it's closed, okay? And I guess we could do the same part for this right here. And we'll do it in blue. So t less than 0, t greater than 0, what happens? So for t less than 0, it's open. And for t greater than 0, it's closed. And I know this because the arrow is signifying that at t equals 0, we are moving it towards the closed position. So before that, it must be open, right? Okay. And let's write down maybe some information that will help us. Okay, well, IL. So IL. So IL of 0 plus and IL of 0 minus, meaning either right before, like infinitely right before, infinitely right after. It's nearly the exact same thing. Okay. And that's just how the current in inductors changes, right? I mean, it doesn't change instantly, right? That's a well-known fact. We have this, so we have a lot of information that will already help us solve. And our equation of use that we're going to use is I of t, IL of t, right? It's equal to I of infinity plus I of 0 minus I of infinity, all multiplied by e to the negative t tau. And then we know that tau is L over R. Okay. So we just have to ask ourselves multiple questions multiple times. And let's start for A. Okay. So I'm going to do everything in A in black so we know the difference. Okay, let's start analyzing it when it was open. So if this was open, so I'm going to draw everything really except this stuff. Well, I'll draw it, but just remember this is open. So 3 amps, we have a source, and then it goes like this. So it's connected, so the 4 ohms is receiving energy. And the 12, all this is open. So this indicating open. And then we got 4, and then we got our inductor. And inductors in DC conditions act like short circuits, okay? Now let me just write that. Inductors at DC equal short circuit. Okay. So since it acts like a short circuit, I can just draw a flat line, right? I can just connect the wire. Okay, and then we know that coming down here is IL. Okay. So 3 amps goes in, and so 3 amps splits between this and this. Okay. So we have 4 resistance here, and we have 4 resistance here. None of the current is going to go here because this is open anyway, so it can't travel down here. So the current's getting evenly split between 4 and 4. So it's literally 3 divided by 2 is equal to IL of what? IL for t less than 0. That's how it works. And we would say that this is all equal to what? 1.5. Or you could leave it as 3/2, but this is just... And also, let me just write that this way too. I'll write it like this. I have 0. There we go. I mean, we found a good amount of information. We found this information. Now we just need to ask what happens if this is closed. So let's quickly draw the same circuit. So 3 amps. And it goes what? It goes 4 ohms. Okay, now since this is closed, there will be some more information we have to deal with. Remember, IL goes down the third route. Okay, so we're only concerned about IL, right? We don't really care what these two currents are, so we could combine these two. So if we combine these two, 4 in parallel 12, okay, that's going to be 48 divided by what? 16, which is 3. So we could redraw the circuit as 3 amps and 3 ohms in parallel with this 4 ohms, and IL comes down here. Okay, now we can use our current division. So IL is equal to the source multiplied by this, right? When we're talking about current, for current division formula, remember we always think about the opposite for the numerator. And then we add them both together, 4 plus 3. And what is this? This is 9 over 7. And this is equal to IL of infinity. Okay. Yeah, well, look at that. We already found enough information. Let's just write down what tau is. Tau is L over R, right? What is the resistance it sees at this point? So IL is right here. Let me draw just another circuit. So we're only concerned about resistance that the inductor sees. And remember, the inductor was right after, so right here. What does it see? Okay, so it sees that there's a 3 ohm, and we could erase this. Well, we could see that R Thevenin is simply just equal to 7. Okay, so then what would tau be? So it'd be, tau would be L. L is 4. R is what? R is 7. Okay, there we go. And all of that means that IL of t is equal to what? So we're going to use this formula. Infinity, it's 9 over 7, so it goes 9 over 7 plus, I have 0. What did we say that was? It was 3 halves. I'll write it like 3 halves instead of 1.5. Minus this, right? Minus 9 over 7. And then this becomes e to the negative t divided by 4 divided by 7. And then we could fix this, write it more nicely. It's 9 over 7 plus 3 over 2 minus 9 over 7 e to the negative 7 over 4 tau. And you could simplify your answer a little bit more with the fraction side there and write it as whatever you want to do, but I'm just going to leave it like that. That's the answer. Okay, my bad. I made a minor mistake. What the inductance is not 4. The inductance is 3.5. So I could edit this really quick and I'll do it in red. Minor mistake. I wanted to show you guys the transparency here. So this is 1/2. And then this is 1/2. So then this turns into what? This turns into -2. Simple, minor error, simple fix. Okay, part 2. Let's hope this is actually not going to be as bad as I think it is, but who knows, it could be a lot easier of a problem than I think. Maybe we'll start by drawing the circuit in its open condition. So 20 volts plus or minus 2, and then, okay, if this is open, oh, okay, look, this is actually not as bad as I thought. So if this is open, this battery right here, I mean, this voltage source doesn't really exist if this is open. So that's kind of nice to know. Yeah, sometimes they aren't as bad as you think. Sometimes they just want to scare you. Okay, and right, this at DC conditions, this is just a flat line. And then we have 3 ohm. Okay, and IL still goes down in this direction. So we want to solve for IL. We know that none of the current is going to go into this 6 ohm resistor because, I mean, why would it? Right? There's no reason for it to. So IL. And the current here is the same through the current of this. So really, the current here, I'm going to do the path of the current. So go like this. That's all that's going to happen. So we could use Ohm's law, where IL is equal to V over R. And what's R? It's going to be 3 and 2. Oh, okay, so it's going to be 20 divided by 3 plus 2 is 5. So it's 4 amps. Okay. And that's what IL is if IL of 0. Okay. Good. That's what we want. We want this information. We do need few more pieces here. Okay, well now we need to know what happens if this circuit is closed. So 20 volts plus or minus. Okay, now I'm going to close it, so now it's going to be plus or minus 48 volts here. God, this is going to be miserable. 2 and 6. And again, flat line for the inductor just draws a flat line. And a 3 ohm resistor. Again, IL comes down here. Okay, so IL. Just for this, right? That's all we care about. So 20 volts, boom, comes in. 48 volts, boom, comes in. Now there's a way we can think about this, right? There's a lot of ways we can find IL. But what if we say that we want to find VL? What if we want to find VL instead? The only reason why I think it might be easier to find a voltage here, because there's a node here, that's the same node here, the same node here, and the same node here. And then we could do nodal analysis for only one node, and everything will probably be easier if we did it this way instead of doing some sort of mesh analysis or some Thevenin equivalent. Let's just apply nodal analysis. Okay. So, right, at this node, what do we see? Well, we see that it's going to be VL minus 20 over 2, right? So VL minus 20 over 2 ohm. Then we see that's going to be VL minus 48 over 6 ohm. And plus VL over 3, which is equal to 0. That's all nice. Let's maybe solve for VL now. So I'm going to decompose it. VL, so only thing's concerned with VL here is 1/2. 48, 1 over 6. And plus 1/3. Minus, okay, now 20 divided by 2 is negative 10. Negative 48 divided by 6. It's 8. Okay. So if I add these, this will be, if I think about them as all a common fraction of 6, this will be 3 plus 1 plus 2. 3 plus 1 plus 2 is 1. I mean, that's 6 over 6, so it's this VL is equal to, and then if I add these two, this is negative 18, and I put on the other side. VL is equal to 18. There we go. That's all nice. Good. Okay. So IL of infinity, that's what we want, is equal to VL divided by RL. And RL is just the resistance right here. Okay. So it's 18 divided by 3, which is 6 amps. Okay. Look at that. Almost everything, we're almost all done with this. We just need to find tau. Okay. So, what is the resistance that it sees? Well, let's iron out all of our independent sources and write this as it should be, where R Thevenin is right here. Okay. So remember we had an inductor here, and then it sees how much resistance does it see? Okay, well it sees that 2 and 6 are in parallel plus 3 in series, so it's going to be 2 parallel 6 plus 3, which, okay, what is this equal to? That's going to be 2 times 6 is 12. 12 divided by 2 plus 6 is 8 plus 3, so it's going to be, oh, okay, so let's simplify this a little bit. Dividing by 4, we get 3 over 2 plus 3, which is going to be, now let's turn this all to a common denominator here. 3 plus 6 over 2 is 9 over 2. Okay. Right. And now we could say that this is 7. Okay, so what else do we want to do here? We want to find tau. Okay, tau is equal to L over R. What is L? L is 2. So it's 2 over 9 over 2, which is 2 over 9 times 2, which is 4 over 9. Okay, so we got everything we need. We just got to put it in the formula now. So, IL of t. What is it equal to? It's equal to I of infinity, so 6 plus, and then I of 0. Where's I of 0? I of 0 is right here. And then minus I of infinity, so minus 6. And e to the negative t divided by tau, which is 4 over 9. Then all of this is going to be equal to 6 minus 2 e to the negative 9 over 4t. That's our answer, just like that. There we go. Consider subscribing and liking if you found this video interesting or helpful. Leave a comment. Just leave any comment, just so I could, get this video pushed up in the algorithm.